Hi, today we'll talk about electricity and magnetism. Learning outcomes. Discuss the concept of electricity, solve problems involving Ohm's law, and explain the concept of magnetism. Current, voltage, and resistance. Voltage is the charge pusher. It causes current to flow or move. Voltage sources are battery, generator, and outlets. Symbol for voltage is capital letter V and the unit for voltage is volts. The volt is named in honor of the 18th to 19th century Italian physicist Alessandro Volta. An Italian physicist known especially for the invention of the electrochemical cell, also known as the battery in 1800. Power utilities use large generators to provide the 120 volts that is delivered to your home outlets. When you plug in something to the outlet like lamp, blow dryer, and TV, the voltage is applied across the circuit, allowing the charge to flow. Current is the flow of charge within a conductor or how fast charge is moving. Charge will only flow if there is a voltage source. Symbol for current is capital letter I and the unit for current is ampere. Named after André Ampère, French physicist and mathematician. One of the main discoverers of electromagnetism. What level of current is dangerous to people? Details are shown in the table below. Resistance opposes the push from the voltage source. It also affects the speed of the current. Symbol for resistance is capital letter R and the unit for resistance is ohms. Unit for resistance is named after Georg Ohm. He is a German physicist. Ohm determined that there is a direct proportionality between the voltage applied across a conductor and the electric current. This relationship is known as Ohm's law. Voltage and current relationship. If the voltage in a circuit increases, the current will increase. If the voltage in a circuit decreases, the current will decrease. This is a direct proportional relationship. Resistance and current relationship. If the resistance in a circuit increases, the current will decrease. If the resistance in a circuit decreases, the current will increase. This is an inversely proportional relationship. Ohm's law states the relationship between current, voltage, and resistance. German physicist Georg Ohm had the law named after him, because of his extensive research. Ohm's law equation is, voltage is equal to the current multiplied by the resistance. Where V is the voltage, I is the current, and R is the resistance. Here are examples. If you want to find voltage in volts, V is equal to I times R. If I is equal to 2 ampere and R is equal to 5 ohms, then, V is equal to 2 ampere multiplied by 5 ohms. The answer is 10 volts. If you want to find resistance in ohms, R is equal to V divided by I. If V is equal to 9 volts and I is equal to 4 ampere, then R is equal to 9 volts divided by 4 ampere equals to 2.25 ohms. If you want to find current in amps, I is equal to V divided by R. If V is equal to 140 volts and R is equal to 2 ohms, then I is equal to 140 volts divided by 2 ohms is equal to 70 ampere. Magnetism. The term comes from the ancient Greek city of Magnesia, at which many natural magnets were found. We now refer to these natural magnets as lodestones, which contain magnetite, a natural magnetic material Fe3O4. Pliny the Elder wrote of a hill near the river Indus that was made entirely of a stone that attracted iron. The Chinese, as early as 121 AD, knew that an iron rod which had been brought near one of these natural magnets would acquire and retain the magnetic property, and that such a rod when suspended from a string would align itself in a north-south direction. The use of magnets to aid in navigation can be traced back to at least the 11th century. Basically, we knew the phenomenon existed and we learned useful applications for it. We did not understand it. Not until its connection to electrical charges and currents was discovered. What is magnetism? Magnetism is the force of attraction or repulsion of a magnetic material due to the arrangement of its atoms, particularly its electrons. What causes magnetism? Atoms themselves have magnetic properties due to the spin of the atom's electrons. Groups of atoms join so that their magnetic fields are all going in the same direction. These areas of atoms are called domains. When an unmagnetized substance is placed in a magnetic field, the substance can become magnetized. This happens when the spinning electrons line up in the same direction. An unmagnetized substance looks like this, while a magnetized substance looks like this. Properties of magnets: there are north poles and south poles. Magnets set up a magnetic field around it. Like poles repel, unlike poles attract. Magnetic forces attract only magnetic materials. And magnetic forces act at a distance. Every magnet has at least one north pole and one south pole. If you take a bar magnet and break it into two pieces, each piece will again have a north pole and a south pole. No matter how small the pieces of the magnet become, each piece will have a north pole and a south pole. Michael Faraday realized that a magnet has a magnetic field distributed throughout the surrounding space. This field exerts a force on any charged magnetic material on it. Field lines converge where the magnetic force is strong, and spread out where it is weak. In a compact bar magnet or dipole, field lines spread out from one pole and converge towards the other. This is according to law of magnetism. Like poles repel, unlike poles attract. Magnets only attract certain types of metals. Other materials such as glass, plastic and wood aren't attracted. Metals such as iron, nickel and cobalt are attracted to magnets. Most metals, however, are not attracted to magnets. These include copper, silver, gold, magnesium, platinum, aluminium and more. They may, however, magnetize a small amount while placed in a magnetic field. Magnetism can attract magnetic objects or push them away. Although two magnets may not be touching, they still interact through their magnetic fields. This explains the action at a distance, say of a compass. That's all for today. See y'all again next time.